Chem Mastery, your study buddies.
Hi everyone, welcome back to topic 3. I hope you all are doing well. So, this video is gonna explain all the tutorial questions for last week's topic. First of all, let's recall what we have learned last week. So, I believe you all already know how to differentiate atomic mass, molecular mass, and formula mass. And we can determine the mass, number of particles, and volume of a gas through mole concept. We also learn how to differentiate the empirical formula and molecular formula. And don't forget the rules of naming a chemical compound and the sequences to balance a chemical equation. For the first question, we need to calculate the percent composition of chlorine in terms of two isotopes, chlorine 35 and chlorine 37. The mass for both isotopes and the average mass of chlorine is given in the question. I hope you are able to solve this. If not, let's move to the solution part together. So first, we know that average mass of a substance equal to sum of all the masses of isotopes. However, we do not know the relative abundance for both isotopes in this question. Bear in mind that the total relative abundance will be 1, and we let Y represent the fraction for chlorine 35. Then the fraction for chlorine 37 is represented by 1 minus Y. Then we substitute all the values into the formula and we'll get Y equal to 0.7576. Since Y equal to 0.7576, so 1 minus 0.7576 will get 0.2424. And remember to multiply 100% to get the final answer. The second question is related to mole concept. Volume of carbon dioxide gas is given and we need to calculate the mass of hydrochloric acid. For your extra information, CuCO3 is actually green in color. Firstly, we need to write down and balance the chemical equation first before we proceed to the calculation. The number of moles can be calculated based on this formula. So, we know that 0.015 mole of carbon dioxide gas was produced. From the equation above, we know that 2 moles of HCl produces 1 mole of CO2. We can do a crossover multiplication to get the number of moles of HCl required to produce 0.015 mole of CO2. We know that mass equal to number of moles multiplied molar mass. So, we calculate the molar mass of HCl from periodic table and then we are able to calculate the mass. In this question, we need to calculate the mass of oxygen used and the mass of potassium used to react completely with oxygen is given. The solution for this question is same with the previous one. It's all about the mole concept. Write the balance equation first as usual. Then calculate the number of moles of potassium with the information given. After that, calculate the number of moles of oxygen gas to react with potassium. And the mass can be obtained if you remember the formula. Mass equal to number of moles multiplied molar mass. Okay. Calculate the number of particles of 2.8 grams of nitrogen gas. So no reaction occurs in this question and no equation is needed because there is only one substance, the nitrogen gas. Since the number of moles of nitrogen gas is fixed, we can let number of particles over Avogadro's constant equal to mass over molar mass. Then substitute all the values given, and now we are able to calculate the number of particles. This question is about definition. You will get your answer correct as long as you got all the key points. Relative atomic mass is the ratio of the average mass of one atom of an element to 1/12 of the mass of carbon-12. Then, 1 mole means that the substance contains 6.02 times 10 to the power of 23 of particles. Empirical formula is the chemical formula that shows the simplest ratio of the number of atoms of each element in a compound, while molecular formula is the chemical formula that shows the actual number of atoms of each element found in a molecule of a compound. You have to know what type of reaction will occur and what are the products produced in this question in order to balance the equations. Alright, let's check the answer for this question together. Number 1, 4, 5, and 7 are neutralization, so a water molecule will be produced. For number 2, to obtain full octet shells, magnesium must lose 2 electrons and chlorine must gain 1 electron. So 1 magnesium atom reacts with 2 chlorine atoms to form magnesium chloride, MgCl2. Number 3 is the reaction between basic oxide with water. Basic oxide is the oxide that gives a base, NaOH, in water. Number 6 is a double displacement reaction. It is a type of reaction in which 2 reactants exchange ions to form 2 new compounds. The answer for naming of compounds will be shown in next slide. Please check whether you get it correct or not. Always remember that first name in the chemical compound is the cation. For example, in sodium oxide, sodium acts as a cation with one positive charge, while oxide, which means oxide anion, carries a 2 negative charge. Hence, 2 sodium ions are required to react with 1 oxide ion. Please take note that the sulfide ion is S2 negative and sulfate ion is SO4 2 negative. And the sulfide ion is SO3 2 negative. This question asks us to find the empirical formula of an organic compound. The combustion of organic molecule use 0.0333 mole of CO2 and 0.599 gram of H2O. We know that this 1 gram organic molecule consists of combination of carbon, hydrogen, and oxygen elements. Hence, we can use X, Y, and Z represent their simplest ratio number. First, we need to calculate the number of moles of each element present in the unknown sample. Since number of moles of CO2 is given, we just need to calculate the number of moles of H2O. We can say that 0.0333 mole of CO2 contains 0.0333 mole carbon atom and 0.0666 mole of oxygen, while 0.0332 mole of H2O contains 0.03332 mole of oxygen atom and 0.0664 mole of hydrogen atom. Then, total number of moles of oxygen is 0.0998 mole. We cannot proceed with the 0.0998 mole of oxygen, as this number of moles of oxygen involve the oxygen gas used. We need to eliminate the number of moles of oxygen in oxygen gas. According to the law of conservation of mass, the mass before a reaction must equal the mass after a reaction. So, mass of reagents equal to mass of products. And then we can write mass of organic molecules plus mass of oxygen equal to mass of carbon dioxide gas plus mass of water. After calculating the mass of CO2, we can determine the mass of oxygen gas. And the number of moles of oxygen in oxygen gas. We use the total moles of oxygen to minus the moles of oxygen gas to obtain the moles of oxygen in organic compound. Then, we are now able to calculate the simplest ratio and finally obtain the empirical formula. We need to determine the volume of nitrogen gas in STP condition and the number of molecules is given in this question. Please take note that the temperature for STP condition is 0 Celsius and the pressure is 1 atmospheric pressure. The molar volume in STP condition is 22.4 dm³ per mole or 24,400 cm³ per mole. So, we use this formula to calculate the number of moles of nitrogen. Next, we use this formula to calculate the volume of nitrogen gas. After substituting all the values into the formula, the final answer will be 5.6 dm³. This question is asking us to determine the empirical formula of sulfur oxide, and it gives us the information that it contains 60% of oxygen based on its mass. The 60% means that there will be 60 grams of oxygen, the remaining 40 grams of sulfur in 100 grams of sulfur oxide. For question involve percentage, we can assume the percentage of the compound as a unit in gram. Always draw a table when you need to determine an empirical formula of a compound. We can get the value for number of moles by using the mass divided molar mass formula. Then, we divided the lowest number of moles to obtain the simplest ratio, and the empirical formula of sulfur oxide is SO3. For the last question, we need to determine the mass of gene. Given that 360 cm³ of hydrogen, H2 gas is released when it reacts with dilute nitric acid. We assume that it is a room temperature condition if question didn't mention it is a STP condition. So, molar volume for room temperature is 24 dm³ per mole or 24,000 cm³ per mole. Always write down and balance the formula first. Then, we can calculate the number of moles of hydrogen gas with the volume given. Since 1 mole of gene produces 1 mole of hydrogen gas in equation, so 0.015 mole of gene produces 0.015 mole of hydrogen gas. Thus, the mass of gene will be 0.981 gram. That's all for today, and we shall end our topic here. Thank you.